This video is about mathematical induction. We will use mathematical induction to prove that its conjecture is true for all positive integers n. CAP method will be used. C for check, A for assume, P for proof. Step 1. Check the statement is true for n equals 1 or n equals m. Step 2. Assume the statement is true for n equals k. Step 3. Prove the statement is true for n equals k plus 1 based on the assumption of step 2. Which means we need to set up a relationship between step 2 and step 3. The statement is true for n equals k. This is a case term. We are looking for k plus 1th term. For linear function, 3k plus 5 for kth term. Next term will be 3 times k plus 1 plus 5. We need to change k into k plus 1. Distributive property, 3k plus 3 plus 5 equals 3k plus 8. For power function a to the kth power, next term will be a to the k plus 1th equals a to the kth power times a. In this way, we connect kth term and k plus 1th term. For a to the 2kth power, next term will be a to the 2 times k plus 1th power equals a to the 2k plus 2th power. That equals a to the 2k times a squared. For summation, next term will be u sub 1 plus u sub 2 plus u sub k plus u sub k plus 1. For sigma notation of summation, next term will be summation I is from 1 to k plus 1 of u sub I. That equals summation I is from 1 to k u sub I plus u sub k plus 1. For nth derivative, kth derivative of f of x, next term will be k plus 1th derivative of f of x equals kth derivative of f of x prime dky dx to the kth. Next term will be dk plus 1 y dx to the k plus 1th equals d dx of dky dx to the kth. For 2nth derivative, next term will be 2 times k plus 1th derivative of f of x equals 2kth derivative of f of x double prime. For d to ky dx to the 2kth. Next term will be d 2 times k plus 1 y dx to the 2 times k plus 1 equals d2 dx squared of dky dx to the kth. For factorial, next term for k factorial is the k plus 1 factorial. That equals k factorial times k plus 1. For 2k plus 1 factorial, next term will be 2 times k plus 1 plus 1 factorial, which is 2k plus 3 factorial equals 2k plus 1 factorial times 2k plus 2 times the 2k plus 3. In this way, we connect kth term and k plus 1th term. Example 1. Proof by mathematical induction that n factorial greater than 2 to the nth power for any n greater than or equal to 4. We use cap. C represents a check. Check the statement is true for n equals 4. Left-hand side of the statement, 4 factorial equals 4 times 3 times 2 times 1 equals 24. Right-hand side of the statement, 2 to the 4th power equals 16. So 4 factorial greater than 2 to the 4th power. This is a step 1. Step 2. Assume the statement is true for n equals k. We will change every single n into k. K factorial greater than 2 to the kth power for any k greater than or equal to 4. The third step, prove the statement is true for n equals k plus 1. We will change every single k in step 2 into k plus 1. K plus 1 factorial greater than 2 to the k plus 1th power. We need to prove this statement based on the assumption. Let's start with the left-hand side equals k plus 1 factorial. We need to set up the connection between k plus 1 factorial and k factorial. That is k factorial times k plus 1. From the assumption, we know k factorial greater than 2 to the kth power. So this expression is greater than 2 to the kth power times k plus 1. Remember, our goal is to get 2 to the k plus 1th power. Let's rewrite this into 2 to the kth power times 2. As long as k plus 1 greater than 2, I can change these expressions into 2 to the k plus 1th power. K plus 1 greater than 2. This is always true because k greater than or equal to 4. So we have this expression is greater than 2 to the k's power times 2. This equals 2 to the k plus 1th power. This is the right-hand side of the statement.